have a coffee?
I will actually like to have a coffee.
Okay.
Can I get a black tea instead of the coffee?
Okay. If it is possible.
Okay.
Same for me.
Okay. Black tea.
Black tea and black coffee.
Okay. Sir, let me have a coffee.
I will actually like to have a coffee.
Okay.
Can I get a black tea instead of the coffee?
Okay. If it is possible.
Okay.
Same for me.
Okay. Black tea.
Black tea and black coffee.
Okay. Sir, let me have a coffee.
I will actually like to have a coffee.
Okay.
Can I get a black tea instead of the coffee?
Okay. If it is possible.
Okay.
Same for me.
Okay. Black tea.
Black tea and black coffee.
Okay. Sir, let me have a coffee.
I will actually like to have a
Sir,
coffee.
let me have a
Can I get a
coffee.
black tea instead of the coffee?
Okay. If it is possible.
Can I get a black tea instead of the coffee?
Black tea. If it is possible.
Okay.
Same for me.
Okay. Black tea.
Hello? Hello?
Yeah, that's okay.
No sound is coming. Can you you How about now? Are you able to hear us now?
They can hear.
Yeah, yes, sir.
Okay.
Okay.
So first start with the any course introduction or about tell about any exam pattern or any topics. We'll start with the learners will auto because now increasing I think so watching
Okay.
increasing.
No, yeah.
Yeah,
They
you can
see.
start means they will if you start any speaking they will listen and they will
Okay.
come.
Okay.
Okay. Okay. So as
This is the intro. If you want.
yeah, okay, we'll just tell about what you might have seen us talking in the introduction of the course. So, this course essentially has two parts. In the first part, or actually part of the course, we will deal with mechanics of fluids alone, the fluid mechanics part, which I would be dealing. And then in the part of the course, you have systems where particles and fluids interact and play a role, and that's what Professor Basav is doing. So you must have seen that we switch or we some of the lectures will be done by me and some of the lectures will be done by him, and yeah.
So yeah, and in terms of fluid particle mechanics, um, I think you would have probably heard this that this course is combination of momentum transfer that people learn in chemical engineering, plus part of mechanical operations. Okay, the filtration is typically dealt in mechanical operations in undergraduate chemical engineering course. So would be topics on sedimentation and things like that. So we've kind of borrowed some stuff from mechanical operations, and most of the stuff in fluid mechanics is retained. So that's why the course is called fluid particle mechanics. So
Yeah,
yeah.
and yeah, so please ask if you have, so far you must have seen many of our lectures. So if you have any doubts, any questions, technically or otherwise, you can ask and we will try to clarify
Yeah.
whatever possible.
Yeah. So and in terms of the exam pattern, it's going to be of similar level as the assignments you have been doing. Okay, I think this week it's assignment 5. Okay, and we will have few more down the course, and the pattern for the final examination is going to be very similar, comparable standards to the assignment that you have been doing. Yeah, and the other thing that you will probably notice in the videos is that these videos are kind of shot at as the course happened in IIT Madras. Okay, so in that context, the course is not tailor made, you know, for the video lecture. So it was kind of real time. So you know, so so in terms of use of the boards and stuff like that, it may be slightly different from what you would have probably seen in a regular course. So there's a question which says, sir, what is physical significance of any quantities material derivatives?
Okay. So see, so typically when you talk about derivative of something, you are actually trying to talk about change of that quantity. So for example, if it is temperature and you want to talk about change in temperature with respect to time, you will simply write a differential. Okay, a d of temperature divided by dt means change in temperature with respect to time. or you could talk about it in space. For example, if you have temperature is changing as a function of space, then you have a dt by dx. So those are ordinary differentials. Now, this is a derivative that's useful when things are moving. For example, we are talking about flow, and in that particular context, what you can do is that things might be changing in both space as well as in time. And not only that, if you look at a particular point, the fluid element that's there at time t will be moving to a different location at a different time. So you want to essentially follow that fluid element and talk about its change. So let's say you're looking at a particular point, a fluid element is existing at that point at time t, and let's say it has got some properties, let's say some temperature, and when you look at the next time instant, it would have moved somewhere else. Okay, you are still at the same fluid element, and you want to talk about the change of temperature of that fluid element. That is when you define a material derivative. Okay, so that's what is the physical significance. So essentially, you are moving with the fluid element and looking at the changes that is happening. So in Navier-Stokes equations that you have seen, we talk about the material derivative of velocity, or actually that's a material derivative of momentum. That's because we know that if you follow a fluid particle, and then if you look at the acceleration of that fluid particle, that is what is related to the force. So that's how the material derivative comes in. So that's what the physical significance of material derivative. And you can define it for any quantities. It could be concentration, it could be temperature, it could be momentum. And those are the kind of things we typically see in chemical engineering. Yeah. So if you, for example, have a problem in which fluid is flowing and temperature is changing, and you want to talk about the temperature change of a fluid element as it flows, and then you will use the material derivative. Is that clear? Yes. Okay. Oops. Any other questions?
Should we ask them, do they find the assignment time consuming or what is
You
it?
can ask. Yeah. Yeah.
So, do you have any feedback on, the assignment level? I mean, do you think they're too easy or moderate level of toughness, or do you think, they're more lengthy? Okay, so if you have any concerns, you can, let us know. We still have, several assignments due, so we could work on, them accordingly, right? So though we finalize these assignments, but still, we would, if you think that, there's something that bothers you about these assignments, we'll be happy to look at them. And if you think, we should make them more tougher, or maybe increase the level of difficulty or decrease the level of difficulty or the length, so we could also work along those lines, if you have any queries. Okay. Lack of proper data we are sometimes not able to answer within the design accuracy.
So see, in the assignments, we generally give a range. For example, if you are expecting an answer of zero point 0.5, then we typically give sufficiently large range, plus or minus 10% at least. So if you report anything between zero point 0.4 and zero point 0.6 for an answer of zero point 0.5, and you are expected to get that score or marks. But now I'm not very sure what you meant by property data, but anything that's required, it must be there in any of the standard textbooks or must be even available online. Um, yeah, if you have, is there anything particular or specific that you did not get? You
So
let
the
us.
other thing that we could do is next time when we frame a problem, we will try and ensure that the property, the data that we have used for whatever calculation, we can give it in the question itself. So you don't have to go to see the other way of looking at this assignment would be, given a problem, you should also learn what is the source that I should go to pick up a table. It could be, if it's a thermo problem, a steam table and stuff like that, right? So the idea of leaving this property data a little open is also that you should learn how to get data if something is not available. But if you think no, for the calculation if it is really making your life difficult, we could give the data as well. The best book for
Best
self.
books for fluid mechanics. So I think in the course we have mostly followed this book by Frank and White, which I find it very nice. And yeah, and the other book as chemical engineers that we find always useful is McCabe and Smith, where many of the things are written, but probably not as much detail as in Frank and White. And I would think at this stage these two books are sufficient and good enough for fluid mechanics part.
Yeah. And again, the fact that McCabe and Smith has been like standing as a textbook for several decades, that basically um, tells us that this is one of the really good books in unit operations. Of course, for particle kind of stuff, you can also look at Coulson Richardson, which is one of again the reference books. But I think for classic fluid mechanics, FM White, would be the best book, I would say.
Sure, thanks.
Yeah. So other thing that you can also do is maybe we will share our email IDs.
Yeah.
You can, Sumesh at iitm.ac.in and Basa at iitm.ac.in. Okay, I mean, if you have questions that for which you need some clarification, or if you guys want to create some kind of a group, email kind of a thing, we could also post your answers there, or we can also do it during one of the next live sessions as well. Okay, so if you have any specific questions, we can also answer through email. But if there's something that has to be addressed to the entire students, definitely we would prefer to do it during live sessions. Okay, so that so that all the information is available for everybody.
How about masters in fluid mechanics?
Um, so I think, I mean, in terms of the masters in fluid mechanics, if you're thinking about masters in fluid mechanics, I don't think there's any specific course where you will see that you'll get to do MS, like say MTech in fluid mechanics kind of a thing. Uh, but the best option would be to think about MS course, which is actually MS by research, and in MS by research you get to work on a problem, and if there is somebody who's working in fluid mechanics area, and if they are doing research in classical fluid mechanics, then you could probably work with that professor, so that then you won't be doing a lot of courses in fluid mechanics. You'll be working on a research problem where fluid mechanics would be involved. That's one possible way to look at it. um, um, but yeah, I mean, we'll search through a little bit and then see if there is uh, MTech course or master's course which is suited for fluid mechanics, but I doubt there's anything that is more specific. You could probably have a little broader branch where more a course connected to fluid mechanics may be available, but in terms of MTech in fluid mechanics or MS in fluid mechanics, you really won't have a course like that.
So this when I look if the course is taught from a chemical engineering perspective, 3D fluid kinematics seems less relevant as the Nevers has pointed out in his book. So the experiment we did in our college with discovered there's a capillary tube-like one in capillary tube.
Sir, the experiment we did in our college with this community, there is a capillary tube like in one.
Clarify the question once again. Ah,
Yeah, so cover all the topics that will be helpful for my GATE exam.
okay, so
Yeah.
yeah.
So yeah, maybe we'll answer the question by, so there's a question which says the experiment we did in our college with viscometer, there is a capillary tube like in one arm of instrument. What is it for? So I assume that this instrument was used for measuring viscosity. Um, so I guess you will also have a bulb in one of the arms. So what is done is this bulb is essentially used for filling a known volume of liquid. Okay, and then what you do is you let this known volume of fluid flow through the capillary, and then you basically find out what is the time it takes to travel a particular distance. Okay, and then there's basically a relationship between the time it takes and the viscosity, so that's how the viscosity is calculated. Okay, that's the capillary tube is essentially for looking at the time that is required for a volume of known fluid to travel a particular distance. Okay, that's what it is used for.
Yeah. So Vinay Kumar, we still haven't understood your question. Can you cover? So the topics that will be covered in the course have already been given to you, I think, in the beginning of the. So it must be listed in the NPTEL website now. The things that we can cover. See, this is a 12 weeks course, and therefore we will be covering as much as possible during that 12 weeks.
Yeah. Yeah, so definitely, I mean, things like in the fluid particle mechanics part, you'll have filtration, fluidized beds, packed beds, sedimentation problems. All of these are classic GATE exam kind of topics. So definitely we have covered all of that, and in the in the fluids part, of course, you have flow through pipes, the flow between cylinders, okay, and turbulence. Okay, all of this is actually are all classic, the GATE exam kind of topic. So definitely, most of the topics will be covered.
week 2 and week 3 were supposed to be 2 different weeks. I student to complete assignment for week 3. So it's the case of the students of my college. Okay, I mean, if you have not been able to complete it, it's okay, but try to keep up with the rest of the course. Um, I am not sure whether we can open the assignment again. We will have to check with our administration whether it is doable. And if that's doable, we will do that and then get back to you. Now, regarding studying basics of fluid mechanics, I don't know. Do you know anything which? Yeah.
This course.
Yeah. Maybe. Yeah. I think this looks like a good course.
So we could, I mean, if you type in, fluid mechanics and NPTEL in Google, I mean, we get one hit, which is again, I think it's a very basic course, wherein the contents that are discussed, it starts with fluid statics, and, the hydrostatic forces and things like that. So I think that will be a good, thing to think about. Um, yeah. So there's a question which says, are the videos are downloadable now?
I
Um,
don't know.
Definitely you should be able to see online. I think all the videos are online now. Most of the videos of the course. In terms of downloadableness, I'm not sure. So we'll have to check with again
Our NPTEL
our
team
our,
here.
our NPTEL team. I think probably they're also listening to our conversation, so maybe they'll get back to you with an answer on the downloadable nature of the videos. So I guess
Hmm.
yeah. So okay, there's a sir, which is the best book for fluid mechanics for second year chemical engineering. Um,
So yeah, so as we said, so for the fluid part, we would suggest Frank M. White and McCabe and Smith, and for the fluid particle mechanics, again McCabe and Smith
and
and Coulson
Coulson
and
and Richardson.
Richardson.
Sir, it will be good if the notes of each week can be provided and also maybe a PDF comprising of conceptual problems.
So most of the things are taken from any of the standard textbooks, and as a student you are expected to um, you know think and go beyond what is done in the class, right? So if so you are expected to therefore go through the books and therefore learn a bit yourself. But if there are specific parts that needs clarification, we can then try
Yeah.
to address
I mean,
them.
because we have also prescribed the textbook that we are going to follow, which is, Frank White and, the McCabe Smith and Particle Technology by Martin Rhodes. If you have access to these books, you will see that the contents are actually directly taken from them. Okay, so in that context, I think I would rather go back to those books and read them up so that so that to make the concepts more clear. Okay, uh, of course the video text can be converted into
Hmm.
a PDF and we could give that, but I think you would probably have access to that.
Yeah, you we thought that you might have access to, but we can check with the team again once
Yeah.
whether
Yeah.
that's doable.
Yeah. And also maybe a PDF comprising of conceptual problems. Um,
So one thing that we have tried to do is to put up some tutorial videos almost every week, where you will see at least a couple of problems solved. So that's one of the things that we have tried to do.
Yeah.
And the other is, of course, the assignments. We have tried to again do the same thing. I mean, the idea of having the assignment is that you try to understand the concept and then try to work out the solutions.
Yeah.
I mean, it's not a fair thing that we work out something and ask you exactly the same thing in the assignment. That's not part of learning anymore, right? So the point is that the concepts are dealt, and then we see whether we are able to use some of them for solving problems.
And also in terms of the conceptual problems, I think, see, if you again look at the assignments, right? Uh, I think we have kind of framed questions which are true, false, which are, multiple choice, so, and, again, these are all again gate type of question. So in that context, I think, all the conceptual problem, things that we want to say, they've already been covered in the assignments, in one or the other form. Okay, so therefore, I think you will probably get a good mix of all kinds of things that one could probably get for a gate exam. Yeah.
Yes, unit operations in chemical engineering.
Yeah.
Maybe.
Yeah. So it's unit. It's called unit operations in chemical engineering.
Yes, I can search in Google and
Yeah, you can also do that.
we'll give you the exact details.
Okay, paste. Yeah. Should we also see the authors?
Hmm. When are we going to get solutions for weekly assignments? I'm not sure whether we have a scheduled session for these things. Hmm.
So what we could do is maybe we could schedule a live session if it's
Yeah,
required.
so what I think you can do is that maybe those questions that you are finding it harder to solve, if you could let us know for the next live session, we could explain those. I think that's probably the best way, because covering all the questions are going to be really time consuming and is probably not necessary. So things which you find it hard, so I think the NPTEL team sends you a Google link where you can ask what are the questions, in which case we will come to know what are the questions to be handled. We will come to know it a priori, and therefore we will be able to do it.
Yeah.
Yeah. I do know about, I mean, I don't know about RK Bansal.
It's civil engineering.
So,
It's more for civil engineering.
okay.
I mean, yeah. So in terms of, in our opinion, see, any book is a. I mean, see, when people write books, they're well thought of. They have either worked in the field or they've done extensive teaching in that particular field. So, in our opinion, any book in fluid mechanics should be okay for you to work with. Okay, we kind of thought FM White is good is because we find it's very comprehensive. It's more suited for chemical engineering kind of audience, right? So that's the reason why we have chosen this. Okay, and if there's a professor who's following RK Bansal for fluid mechanics, is perfectly fine. I mean, I'm sure that every book has some unique aspects. So in that context, we are okay if you're referring any book. And if I remember correctly, I think R.K. Bansal is probably written by somebody who's a civil engineer. I think it's more kind of suited to civil engineering audience. Um, but for chemi folks, we would think that F.M. White is a better book.
So for, I do not know, the question is the body whose surface does not coincide with the streamline when placed in a flow. So as far as if you keep any body in the fluid, the surface will be a streamline. So I don't see why there should be a case where it's not.
Are you
Or
talking? Are you talking about the orientation of the body itself? So are you talking about a case where, if you have like say a non-spherical particle, it's aligned with the flow and it is not aligned with the flow? Is that what the question about, or is it more specific to um, the surface coinciding with the streamline? It's a bluff body, right?
is it what they are talking
See, there's a if the particle is aligned with the flow,
about?
it's called it has some name. Yeah, sorry. If you can please consider a constructive comment from my side, I have seen.
Audio for course lectures as well. Okay, we will convey that message to our technical team about the quality of audio.
Yeah. Yeah. Yeah, I mean, again, any questions that you have about, you know, of course, the videos are already shot and finalized. Okay, we can't, we will still try our best to, change a few things if we can, because we still have, sufficient time to go, right? But in terms of, the other things, wherever we can make changes, we would be happy to do it. Okay, I mean, any comments that you have, to do, send it to us either in this live session or send us an email. We would be happy to work with you guys, to make things better. Yeah.
So if you have no more questions, then we will wind up the session. So if you have anything, please write. We'll wait for another couple of minutes. So I think, as we have pointed out, we would suggest you to use these 3-4 books that we have stocked so far. Um,
I don't know. See this question about, the practice numericals from gate point of view, which is the best book. I think this question is very difficult to answer. The way probably I would have approached this would be take a look at the last few years of gate question papers, look at, what kind of fluid mechanics problems are asked, and you just see, and if you can familiarize with the concepts related to those problems, definitely it will help you guys, in definitely approaching, how to solve the problem, so yeah, I think if your basics are good, if you learned your concepts well, then it really doesn't matter. See, I don't think there's a set of 10 practice problems and you solve this and you can crack gate, right? There's nothing like that. So the whole idea is, you get your basics right. If you understood the concepts well, and then you should be able to do the problems. So yeah, uh, yeah. Because we don't really have any specific book that you would have to follow for gate, right? I think the gate, if you look at the gate, the
Syllabus.
syllabus, they would have given, look, fluid mechanics, these concepts, right? That's all that is given. So you should,
Yeah,
you
also
can.
realize that gate is not. Gate questions are not set by not referring to a particular book.
Yeah.
It's set by different people in different years at different points of time. So there is nothing like you study this book and you can do gate. That's not the idea. The idea of the questions are to check whether you have understood the concept. So your aim should be to understand the concept, and then if you have understood something, you will be able to do that question.
Yeah.
Now, regarding the last question, the animations for explaining courses, we try to do that. So maybe in the first few weeks, we might not have used as much, but you will see that at later point, whenever required, we have tried to include few videos and so on in explaining things.
Okay. Need to
So this one, I think that's in the forum.
Okay.
We need to check that
Okay.
information.
Yeah, so for some, this is to address the question. I'm concerned by the late reply of the queries that I had posted to last week. See, somehow we had not had maybe a direct access to the forum questions. So I think with the mail IDs that we have shared, right? You please do write to us directly.
No, I think we will try to look at the
So
forum
we
probably more
what yeah, maybe we
regularly.
haven't done the four because we are also doing this NPTEL course for the first time. So so what we'll do is we will watch out the forum more carefully. Plus, you're also free to write to us on the email ID, so that it's on our email, and we'll be able to respond much more quickly than going to the forum. Um,
We will not do much about viscometers or flow meters anymore. Yeah.
But what we can do is, I can send you some, relevant source for learning more about viscometers and flow meters. See, McCabe and Smith does cover a good bit of flow meters. All the pitot tube, the venturi meter, orifice meter. All of them are covered reasonably well. But in terms of viscometers, you won't see much of it in the McCabe and Smith. But I think FM White does have some this the capillary viscometers and the falling ball viscometers. A fair bit of it is covered in FM White. But if you want to look at more advanced kind of viscometers, like see, there are what are called as rheometers, which are basically based on kind of relating the well-developed flow between different geometries. Like you have a parallel plate, and the fluid is in between them, and one of them is rotating, other one is stationary. Or if you have two concentric cylinders, okay, and the fluid is kind of filled between the cylinders, and one of them rotating and the other one is stationary, right? For these things, the fluid mechanics kind of is worked out well, right? In terms of solving Navier-Stokes equation, I think one of the book where you can find nice details about all of this would be your transport phenomena by BSL, Bird, Stewart, and Lightfoot. It has all these derivations very nicely done, wherein you can actually relate the shear stress to viscosity and other stuff, right? So maybe you can look up, some of these things in BSL, a little bit in fluid, FM White, and a little bit in McCabe and Smith. Yeah.
So just one comment again regarding flow meters, just like BSL, there's various flow meters are nicely written up in both McCabe and Smith and FM Wide. And you can see that it's a lot of theory that you can read, and it's not really worth teaching that in a class. So that's one of the reason why we didn't try to do that. So you can try to read up more about from these books on flow meters as well.
Yeah, so experimental videos, yeah, maybe we'll think about it. I mean, if again, we may have to shoot new videos. Okay, we'll just check with the NPTEL team, and of course, in our lab we do use viscometers and rheometers and all of them fairly regularly, right? So we could definitely have some video. I think more details about this viscometers and rheometers. What you can do is there is a course by someone called Professor Abhijit Deshpande.
Satish, is there a timing given to them? 1 hour.
So I'm just going to post, a course, details of a particular course, okay, which is going to, I'm going to do it now. Maybe you can look at some course contents from these, these courses. Okay, this course is something called as rheology of complex materials. Definitely some of the things that we have mentioned as an answer to the last question, I'm sure you will find a lot of information in this course, and of course we'll think about putting up some videos if we can. Yeah. there are no questions, we will leave. Oh.
Trying to make it as simple as possible.
So there's a question which says try to make as simple as possible. Um, See, I mean, see, the course is kind of intended for different people with different needs, right? There could be some people taking this course just as a course, as a substitute for one of the course that you're doing in you know in a in your in your college, and there could be some people who would be looking at this course maybe purely from a gate point of view, right? So this is the objective that we have at our hand is to really cater to everybody, right? So therefore I think the way we have pitched at the course, I mean, it's at a similar level. We teach the people in this institute. Okay, so in that context, we would and the assignments kind of give you a flavor of what to expect in the course. Okay, and the videos are there to tell you, what what you should be thorough with, in order to in order to work out these assignments. So I think, as long as you're thorough with the content that are discussed in the videos, and then have one or two reference books and refer to them once in a while, um, that should help you guys out.
Yeah.
Okay, I don't think we will ask anything that is beyond what is done in the class. Okay, so it's all about being attentive and listen to the course videos, make sure that you do the assignments. I think that will help everybody.
Yeah.
That's something.
Yeah. You also have the choice of watching it multiple times, right? I mean,
Yeah.
the same video. So that should also help you. Against okay. So looks like you have no more questions. So we are winding up the session, and we'll see you in the next live session.
Okay, thank you so much.